Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper Math P4 Variant 1 May-June 2022. Let's get started. The list shows 15 midday temperatures in degrees Celsius in Sandtown. Complete the statement leaf diagram to show this information. The key has been given to be 1/7 represents 17 degrees Celsius. For the next temperature in the list, which is 21 degrees Celsius, since the first number is 2, we come to this line and write 1. We need to repeat the same process for the rest of the temperature values. When we are done, we need to ensure that the numbers on each line are arranged in ascending order. Find the median. To get the position of the median, we use the formula half n plus 1, where n in this case is 15. This gives us 8. The temperature in the 8th position is 21 degrees Celsius. Find the upper quartile. To get the position of the upper quartile, we use the formula 3/4 times n plus 1, where n in this case is 15. This gives us 12. The temperature in the 12th position is 23 degrees Celsius. Rahul draws a pie chart to show this information. Calculate the sector angle for the number of days the temperature is 18 degrees Celsius. This sector angle is equal to the number of days the temperature is 18 degrees Celsius, which is 2, divided by the total number of days, which is 15, times 360 degrees. This gives us 48 degrees. The box and whisker plot shows information about the masses in grams of some apples. Find the median. From the plot, the median is 120 grams. Find the range. The range is equal to the highest value, which is 170 grams, minus the lowest value, which is 40 grams. This gives us 130 grams. Find the interquartile range. The interquartile range is equal to the upper quartile, which is 140 grams, minus the lower quartile, which is 80 grams. This gives us 60 grams. The time T minutes spent on homework in 1 week by each of 200 students is recorded. The table shows the results. Calculate an estimate of the mean. Before we get the estimate of the mean, we need to find the midpoint of the given time intervals. So for the first interval, the midpoint is 40 plus 60 divided by 2, which is 50. Then we have 60 plus 80 divided by 2, which is 70. 80 plus 90 divided by 2, which is 85. 90 plus 100 divided by 2, which is 95. 100 plus 150 divided by 2, which is 125. So the mean is equal to the total amount of time, which is 50 times 6 plus 70 times 10 plus 85 times 70 plus 95 times 84 plus 125 times 30 minutes divided by 200. When we type this into the calculator, we get 93.4 minutes. A new table with different class intervals is completed. On a histogram, the height of the bar for the t is greater than 40 and less than and equal to 90 interval is 17.2 centimeters. Calculate the height of the bar for the t is greater than 90 and less than and equal to 150 interval. On a histogram, the frequency density gives us the height of the intervals. For this interval, the frequency density is equal to the frequency, which is 114, divided by the interval width, which is 150 minus 90. This gives us 1.9. And for this interval, the frequency density is 86, divided by 90 minus 40, which is equal to 1.72. The actual height of this interval on the histogram is 17.2 centimeters. This means 1.72 times a certain scale factor, which we are going to call K, is equal to 17.2 centimeters. When we divide both sides by 1.72, we get K equals 10. So now, the height for the t is greater than 90 and less than and equal to 150 interval is 1.9 times 10 centimeters, which is equal to 19 centimeters. Alex, Bobby, and Chris share strawberries in the ratio Alex is to Bobby is to Chris equals 3:2:2. Chris receives 12 strawberries. Calculate the total number of strawberries shared. The number of strawberries Chris receives, which is 12, is equal to the ratio share for Chris, which is 2, divided by the total ratio, which is 7, times the total number of strawberries shared, which we are calling T. When we make T the subject, this is what we get, which is equal to 42. In a sale, a shop reduces all prices by 12%. Dana buys a book which has an original price of $6.5. Calculate how much Dana pays for the book. If the original price is reduced by 12% during the sale, we subtract 12% from 100%, which gives us 88%. So the sale price of the book is 88% of the original price, which is $6.5. This gives us $5.72. Elu pays $11 for a toy. Calculate the original price of the toy. The sale price of the toy, which is $11, is equal to 88% of the original price. When we divide both sides by 88%, we get the original price to be $12.5. Ferry invests some money. The rate of interest for the first year is 2.5%. At the end of the second year, the overall percentage increase of Ferry's investment is 6.6%. Find the rate of interest for the second year. Let's represent the amount of money Ferry invests with X. If the rate of interest for the first year is 2.5%, then the amount of money he has at the end of the first year is X plus 2.5% of X, which is equal to 1.025X. Let's represent the rate of interest of the second year with Y. So the amount of money Ferry has at the end of the second year, which is X plus 6.6% of X, is equal to the amount of money he earned from the first year, which is 1.025X, plus the interest he earned for the second year, which is Y% of 1.025X. Y% of 1.025x is 0.01025xy. X plus 6.6% of x is 1.066x. When we subtract 1.025x from both sides, this is what we get. When we divide both sides by 0.01025x, this is what we have. X cancels out. When we type 0.041 divided by 0.01025 into the calculator, we get 4. A radioactive substance decays at an exponential rate of 2% per day. The initial mass is 80 grams. Find the mass at the end of 5 days. In this case, we need to apply the compound or exponential formula. Since we are dealing with a decrease or a decay in this case, we bring a minus here. Big A represents the final mass of the substance, which is what we are finding. Small a represents the initial mass of the substance, which is 80 grams. R is the daily rate of decay, which is 2%, and T is the number of days for the decay, which is 5. When we type this into the calculator, we get 72.3 grams, rounded to 3 significant figures. Find how many more whole days after day 5 it takes for the mass to reduce to less than 67 grams. We need to apply the exponential formula in this case as well. Big A represents the final mass of the substance, which is 67 grams. Small a represents the initial mass of the substance, which is its mass on day 5, and that is 72.3 grams. We've been given the daily decay rate to be 2%, and we are asked to find T, which is the number of days after day 5 the mass reduces to less than 67 grams. When we divide both sides by 72.3, this is what we have. 1 minus 2% is 0.98. To get T, we apply the basic definition of log, and this is what we get. When we type this into the calculator, we get 3.77. This means it takes 4 whole days after day 5 for the mass to reduce to less than 67 grams. Gita buys X apples, X plus 7 oranges, and 2X minus 1 bananas. The total number of pieces of fruit Gita buys is 30. Find the number of apples Gita buys. The sum of X plus 7 and 2X minus 1 is 30. When we group like terms, X plus 2X is 4X and 7 minus 1 is 6. When we subtract 6 from both sides, we get 4x equals 24. And when we divide both sides by 4, we get x equals 6. The cost of one apple is 15 cents. The cost of one orange is 18 cents. The total cost of all the fruit is $5.55. Find the cost in cents of one banana. Let's represent the cost of one banana with x. So the cost of getting the apples, which is 6 times 15 cents, plus the cost of getting the oranges, which is 13 times 18 cents, plus the cost of getting the bananas, which is 11x, is equal to $5.55, which is 555 cents. 6 times 15 plus 13 times 18 gives us 324. When we subtract 324 from both sides, we get 11x equals 231. When we divide both sides by 11, we get x equals 21. Solve 3w divided by 16 minus 1 equals 1 over 2. When we add 1 to both sides, we get 3w over 16 equals 1.5. When we multiply both sides by 16, we have 3w equals 24. And when we divide both sides by 3, we get w equals 8. Find the value of y. When we compare the given equation to the previous equation, we see that 2 raised to the power negative y equals w. We found w to be 8. 8 can be written as a base of 2, which is 2 cubed. Now that the bases on both sides of the equation are equal, then their powers must also be equal. So negative y equals 3. When we divide both sides by negative 1, we get y equals negative 3. Solve the simultaneous equations. First, let's label the given equations. Let's use the elimination method. Since we have plus q in equation 1 and minus q in equation 2, we can eliminate q by adding equation 1 to equation 2. This gives us 3p equals 1.5. When we divide both sides by 3, we get p equals 0.5. So now we can plug in the value of p into any of the equations to get the value of q. If we pick equation 1, we have 2 times 0.5 plus q equals 2. 2 times 0.5 is 1. When we subtract 1 from both sides, we get q equals 1. Hence, for u is greater than and equal to 0 degrees and less than and equal to 360 degrees, and v is greater than and equal to 0 degrees and less than and equal to 360 degrees, solve the simultaneous equations. When we compare the given set of simultaneous equations to the previous set, we see that sin u equals p and cos v equals q. We found p to be 0.5 and q to be 1. To be able to find all the possible values of u in the given range, we need to find theta, which is the sine inverse of the positive value of 0.5, which is the same as 0.5. This gives us 30 degrees. Now we draw the quadrants. Sine is positive in these quadrants, so we measure theta from the horizontal axis in these quadrants. When we go around the quadrants the first time, u equals 30 degrees. And when we go around the quadrants the second time, u equals 180 degrees minus 30 degrees, which is equal to 150 degrees. To be able to find all the possible values of v in the given range, we need to find theta, which is the cosine inverse of the positive value of 1, which is the same as 1. This gives us 0 degrees. Now we draw the quadrants. Cosine is positive in these quadrants, so measuring 0 degrees from the horizontal axis would be the same as the horizontal axis. So the first possible value of v is 0 degrees. When we go around the quadrants the second time, we get the second possible value of v to be 360 degrees. Find f of 2. To get f of 2, we replace x in f of x with 2. So we have 2 times 2 minus 1, which is equal to 3. Find g of f of 2. To get g of f of 2, we replace x in g of x with f of 2, which we found to be 3. So we have 3 times 3 minus 2, which is equal to 7. Find g inverse of x. G of x is 3x minus 2. To get g inverse of x, we replace g of x with x and replace x with y. When we make y the subject, we get y equals x plus 2 divided by 3. This expression we have for y is the same as g inverse of x. So g inverse of x is also equal to x plus 2 over 3. Find x when h of x equals j of negative 2. H of x, which is 1 over x, is equal to j of negative 2, which we get by replacing x in j of x with negative 2, giving us 5 raised to the power negative 2. When we make x the subject, this is what we have, which is equal to 25. Write f of x minus h of x as a single fraction. F of x is 2x minus 1 and h of x is 1 over x. 2x minus 1 has a denominator of 1. So to get the LCM, we multiply 1 by x, giving us x. For 2x minus 1 over 1, since we are multiplying the denominator by x to get the LCM, we also need to multiply the numerator by x. So x times 2x minus 1 gives us 2x squared minus x. For 1 over x, Since we multiply the denominator by 1 to get the LCM, we also need to multiply the numerator by 1. So 1 times 1 is 1. So we have 2x squared minus x minus 1 over x. Find the value of j of 2. First, let's find j of 2. To get j of 2, we replace x in j of x with 2. This gives us 5 squared, which is equal to 25. So now to get j of 2, we replace x in j of x with j of 2, which we found to be 25. So we have 5 raised to the power 25, which is equal to 2.98 times 10 raised to the power 17. Find x when j inverse of x equals 4. J of x is 5 raised to the power x. To get j inverse of x, we replace j of x with x and replace x with y. Y, which is the same as j inverse of x, has been given as 4. 5 raised to the power 4 is 625. ABCDEFGH is a regular octagon with sides of length 6 cm. The diagram shows parts of the octagon. O is the center of the octagon and M is the midpoint of AB. Show that angle OAM is 67.5 degrees. Angle OAM is half the interior angle of the regular octagon. To get the interior angle of the regular octagon, we apply the formula 180 degrees times n minus 2 divided by n, where n in this case is 8. This gives us 135 degrees. So angle OAM is 135 degrees divided by 2, which is equal to 67.5 degrees. Calculate the area of the octagon. The area of the octagon is equal to 8 times the area of triangle OAB. The area of triangle OAB is half times AB times OM. AB is 6 centimeters. To get OM, we apply SOHCAHTOA. This gives us tan of 67.5 degrees equals OM divided by 3 centimeters. When we make OM the subject, we get 3 tan 67.5 centimeters. When we type this into the calculator, we get 174 centimeters squared, rounded to 3 significant figures. Find the area of the circle that passes through the vertices of the octagon. Here is the formula for the area of a circle. We need to find the radius r of the circle, which in this case is OA. To get OA, we apply SOHCAHTOA. This gives us cos 67.5 degrees equals 3 centimeters divided by OA. When we make OA the subject, this is what we have. When we plug in the value of OA into the area of a circle formula, this is what we get. When we type this into the calculator, we get 193 centimeters squared, rounded to 3 significant figures. The diagram shows a horizontal container for water with a uniform cross-section. The cross-section is a semicircle. The radius of the semicircle is 0.45 meters and the length of the container is 4 meters. Calculate the volume of the container. Here is the formula for the volume of the container. The cross-section of the container is a semicircle, and the area of a semicircle is pi r squared over 2, where the radius r in this case is 0.45 meters. The length L is 4 meters. When we type this into the calculator, we get 1.27 meters cubed, rounded to 3 significant figures. The greatest depth of the water in the container is 0.3 meters. The diagram shows the cross-section. Calculate the number of liters of water in the container. Give your answer correct to the nearest integer. To get the volume of the water, we multiply the cross-sectional area of the water by the length of the water in the tank, which is 4 meters. To get the cross-sectional area of the water, we subtract the area of triangle ABC from the area of sector ABC. Before we get the area of the sector and triangle, we need to find angle ABC. Angle ABC is 2 times theta. To get theta, we apply SOHCAHTOA. This gives us cos theta equals 0.15 meters divided by 0.45 meters. When we make theta the subject, this is what we get. When we type this into the calculator, we get 70.529 degrees. So now angle ABC is 2 times 70.529 degrees, which is equal to 141.058 degrees. Now that we found angle ABC, the area of sector ABC is 141.058 degrees divided by 360 degrees times pi 0.5 squared, and the area of triangle ABC is half times 0.45 times 0.45 times sine of 141.058 degrees. When we type this into the calculator, we get 0.1856 meters squared. So now the volume of the water is 0.1856 meters squared times 4 meters, which is equal to 0.7424 meter cubed. To convert this to liters, we multiply by 1000. This gives us 742 liters, rounded to the nearest integer. The diagram shows the graph of y equals f of x for x is greater than and equal to negative 1.5 and less than and equal to 5. Find f of 2. In other words, we are to find the y value of the graph when the x value is 2. On the grid, when we map x equals 2 onto the graph, we get y equals negative 3. Solve the equation f of x equals 0 for x is greater than and equal to negative 1.5 and less than and equal to 5. In other words, we are to find the x values of the intersection points between the graph of y equals f of x and the line y equals 0, which is the x-axis. On the grid, we see that the x values of these points are negative 1, 1.6, and 4.4. F of x equals k has 3 solutions. For x is greater than and equal to negative 1.5 and less than and equal to 5, where k is an integer. Find the smallest possible value of k. In other words, we need to find the line y equals k, which cuts the graph at 3 points, where k is the smallest integer. On the grid, we see that k is negative 8 because the line y equals negative 8 has the smallest possible value of k that cuts the graph at 3 points. On the grid, draw a line y equals mx so that f of x equals mx has exactly one solution. For x is greater than and equal to negative 1.5 and less than and equal to 5. The line y equals mx is a line that passes through the origin. So we need to draw y equals mx such that it cuts the graph of y equals f of x at only one point. On the grid, we've drawn the line y equals mx. Y equals 3x squared minus 12x plus 7. Find the value of dy dx when x equals 5. When we differentiate y, we get dy dx equals 6x minus 12. When we plug in x equals 5 into dy dx, we have 6 times 5 minus 12, which is equal to 18. Find the coordinates of the points on the graph of y equals 3x squared minus 12x plus 7, where the gradient is 0. Where the gradient is 0, dy dx equals 0. So we have 6x minus 12 equals 0. When we group like terms and divide both sides by 6, we get x equals 2. So now we know that the x value of the point where the gradient is 0 is 2. To get the corresponding y value, we plug in x equals 2 into the equation of the graph. This gives us 3 times 2 squared minus 12 times 2 plus 7, which is equal to negative 5. So we have 2 negative 5. Find the value of P and the value of Q. We've been given y equals 2x raised to the power p plus qx squared. When we differentiate y, we get dy dx equals 2px raised to the power p minus 1 plus 2qx. When we compare this to the dy dx we've been given, we see that 2p equals 14 and 2q equals 6. When we divide both sides by 2, we get p equals 7 and we get q equals 3. Calculate angle ACD. To get angle ACD, we apply the cosine rule to triangle ACD. This gives us AD squared equals AC squared plus CD squared minus 2 times AC times CD times cosine of angle ACD. When we make angle ACD the subject, this is what we get. AD is 9 kilometers, AC is 14 kilometers, and CD is 12 kilometers. When we type this into the calculator, we get 39.6 degrees rounded to 1 decimal place. Show that BC equals 7.05 kilometers, correct to 2 decimal places. To get BC, we apply the sine rule to triangle ABC. This gives us BC divided by sine 25 degrees equals 14 kilometers divided by sine 123 degrees. When we make BC the subject, this is what we get. When we type this into the calculator, this is what we have, which is approximately 7.05 kilometers rounded to 2 decimal places. Calculate the shortest distance from B to AC. The shortest distance from B to AC is the perpendicular distance from point B to AC, which we've labeled as y. To get y, we apply SOHCAHTOA. This gives us sine 32 degrees equals y divided by 7.05 kilometers. When we make y the subject, this is what we get. When we type this into the calculator, we get 3.74 kilometers rounded to 3 significant figures. Calculate the length of the straight line BD. To get BD, we apply the cosine rule to triangle BCD. This gives us BD squared equals BC squared plus DC squared minus 2 times BC times DC times cosine of angle BCD. BC is 7.05 kilometers, DC is 12 kilometers, and angle BCD is 39.6 degrees plus 32 degrees, which is equal to 71.6 degrees. When we plug in these values into the equation and make BD the subject, this is what we get, which is equal to 11.8 kilometers rounded to 3 significant figures. C is due east of A. Find the bearing of D from C. In the illustration, we've indicated the bearing of D from C. We are told C is due east of A. This means the bearing of A from C is 270 degrees. So the bearing of D from C is 270 degrees plus 39.6 degrees, which is equal to 309.6 degrees. Use set notation to describe the shaded region in the Venn diagram. The shaded region is common to A and B. This can be described as A intersection B. Shade the correct region in each Venn diagram. For this Venn diagram, we are to shade Q union P complement. In other words, we are to shade the region Q in addition to the region outside set P. For this Venn diagram, we are to shade K union L intersection M complement. In other words, we are to shade the region K union L that is outside set M. The diagram shows 11 cards. One of these cards is chosen at random. Write down the probability that the letter on the card is not A. This probability is equal to the number of cards that do not have an A, which is 9, divided by the total number of cards, which is 11. A card is chosen at random from these 11 cards and then replaced. A second card is then chosen at random. Find the probability that exactly one card has the letter N. The probability that the first card chosen has the letter N is equal to the number of cards with the letter N, which is 2, divided by the total number of cards, which is 11. This card is replaced, so the probability that the second card does not have the letter N is equal to the number of cards that do not have the letter N, which is 9, divided by the total number of cards, which is 11. The order in which these two cards are picked may be reversed, so we multiply this by 2. When we type this into the calculator, we get 36 over 121. Complete the Venn diagram. We are told 3 students do not like English and do not like mathematics. So we put 3 in this region outside sets E and M. Let's represent the number of students who like English and mathematics with X. Since 33 students like English, then the number in this region would be 33 minus X. And since 42 students like mathematics, the number in this region would be 42 minus X. So now let's find the value of X. We know there are 50 students in total and 3 of these students do not like English and do not like mathematics. So if we sum up 33 minus X, X and 42 minus X, we should get 50 minus 3, which is 47. When we simplify this and make X the subject, we get X equals 28. Now we know the value of X, so the number in this region is 28. And in this region, we have 33 minus 28, which is equal to 5. And in this region, we have 42 minus 28, which is equal to 14. A student is chosen at random. Find the probability that this student likes English and likes mathematics. This probability is equal to the number of students who like English and mathematics, which is 28, divided by the total number of students, which is 50. 2 students are chosen at random. Find the probability that they both like mathematics. The probability that the first student chosen likes mathematics is equal to the number of students who like mathematics, which is 42, divided by the total number of students, which is 50. After the first student is picked, the pool reduces by 1. So the probability that the second student also likes mathematics is 41 over 49. When we type this into the calculator, we get 123 over 175. 2 students who like English are chosen at random. Find the probability that they both also like mathematics. The probability that the first student chosen from the English group also likes mathematics is equal to the number of students who like English and mathematics, which is 28, divided by the number of students who like English, which is 33. After the first student is picked, the pool reduces by 1. So the probability that the second student also likes English and mathematics is 27 over 32. When we type this into the calculator, we get 63 over 88. Find the value of k. You must show all your working. We are told k is the difference between the perimeters of the two shapes. The perimeter of the rectangle is 2 times x minus 1 plus 2 times 2x plus 1, and the perimeter of the square is 4x. When we expand the brackets, 2 times x is 2x. 2 times negative 1 is negative 2. 2 times 2x is 4x. 2 times 1 is 2. When we group like terms, minus 2 plus 2 is 0. 2x plus 4x minus 4x is 2x. Now that we know the value of k is 2x, we need to find the value of x. We are told the area of the rectangle is 29 centimeters squared greater than the area of the square. This means the area of the rectangle is equal to the area of the square plus 29. The area of the rectangle is x minus 1 times 2x plus 1, and the area of the square is x squared. When we expand x minus 1 times 2x plus 1, we get 2x squared minus x minus 1. When we move all the terms to one side of the equation and group like terms, we have x squared minus x minus 30 equals 0. We can solve for x using the factorization method. We can rewrite minus x as 5x minus 6x. For the first two terms, when we factor out x, we are left with x plus 5. And for the final two terms, when we factor out minus 6, we are left with x plus 5. We can rewrite this as x plus 5 times x minus 6. When we equate x plus 5 to 0, we get x equals negative 5. And when we equate x minus 6 to 0, we get x equals 6. In this case, the value of x, which represents the side length of the square, cannot be negative. So k equals 2 times 6, which is equal to 12. Show that 3y squared plus 3y minus 4 equals 0. We are told the volume of the larger cube is 5 centimeters cubed, greater than the volume of the smaller cube. This means the volume of the larger cube equals the volume of the smaller cube plus 5. The volume of the larger cube is y plus 1 cubed, and the volume of the smaller cube is y cubed. When we expand y plus 1 cubed, we get y cubed plus 3y squared plus 3y plus 1. When we move all the terms to one side of the equation, this is what we have. When we group like terms, we get 3y squared plus 3y minus 4 equals 0. Find the volume of the smaller cube. Show all your working and give your answer correct to 2 decimal places. We know the volume of the smaller cube is y cubed, so we need to find the value of y. To get y, we solve the quadratic equation we got from the previous question. When we apply the quadratic formula to the equation, this is what we have. The numbers under the square roots, 3 squared minus 4 times 3 times negative 4 gives us 57. And for the denominator, 2 times 3 is 6. For the first possible value of y, we get 0.7583. And for the second possible value of y, we get negative 1.7583. In this case, y, which represents the side length of the cube, cannot be negative. So the volume of the smaller cube is 0.7583 centimeters cubed, which gives us 0.44 centimeters cubed, rounded to 2 decimal places. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.